Yeah.
Welcome to Ep.3 of The Social Brain with your hosts, me, Andrew Cooper Sansone, and Taylor Guthrie. I run the channel Sense of Mind, and it's all about neuroscience and whatnot. But today we are going to be talking about getting on the same wavelength. So we're going to be talking about the phenomena of neural synchronization and shared representations in the brains of multiple people in social situations. So that will all become clear as we go. But one kind of general thing that emerges from this research is that when people are in conversation, their brains tend to kind of sync up, and we'll get into what exactly that means, but they tend to show similar patterns of brain activation. And so throughout this conversation, what we want you to keep in mind is that not only are Taylor and I, as since we're in conversation, our brains are going to look pretty similar throughout the course of this conversation, but you listening to this and understanding what we're saying will also make your brain kind of resemble ours. And I should say Taylor is an expert in this area, so he's probably going to correct everything I just said, but I'm going to hand it off to him now.
No, I think that's right on the mark. And what's really cool about this field in general is that we're moving towards what a lot of scientists call a two-person neuroscience. The ability to really look at two different brains at the same time and see what's going on while they're interacting with one another, while they're cooperating or competing with one another. The research on this has just kind of exploded in the last 5 to 10 years, and it's been absolutely fascinating. And I mean, I know that most people have this kind of intuitive sense of feeling understood by other people. When you're in a conversation, you have that feeling of like we're on the same page, we're on the same wavelength. What we're going to kind of get into today is that there may be something biological actually going on that's prompting that feeling. Our brains may actually be on the same wavelength, so to say. And what's really fascinating, and what I think a lot of the listeners can kind of relate to, is that this is a lot more salient with people that we're really close to, with close friends, with romantic partners, that feeling of just really being in tune with the other person. It's really cool that the research is really starting to catch up and gives some type of a biological explanation for why we kind of get into that zone and that mode.
Yeah. Well, I think we're ready to pretty much jump into it. There we go. I kind of changed the layout of the screens there, but anyway, so this conversation is going to be a little bit different than some of our others that we've done. I'm going to be kind of asking Taylor some questions, but we're also just going to be conversing about these different things because, as we'll get into, Taylor's done some research in this area and really knows a lot about it. But as first off, I think we just want to kind of talk about the psychological phenomenon that is best captured, I think, by the quote or the saying that birds of a feather flock together. So why is it, or maybe we can just mention some of the ways that people associate with people who are similar to themselves?
Yeah, it's I mean, in the psychological literature, I mean, this has been documented for 100 years. And I mean, it's something intuitive that we kind of understand already. It's this idea called homophily, that people that are very similar to one another tend to kind of group together. Also, people that are just kind of close to one another in proximity with each other just really start to gravitate towards one another. But you see this across tons of different demographics. So people that are around the same age tend to group together. People that are the same kind of culture, nationalities tend to group together. And so it's really kind of a cool jumping off point. We've known that this is something that has been prevalent in the psychological research for so long. And it's really cool that we're now starting to kind of dig into that a little bit from kind of this neuroscience perspective and see whether or not these things that we've known about, people that have the same beliefs, people that have the same attitudes, is there something going on in their brain that's kind of prompting this coming together?
Right. Yeah, and I think one way we can also look at this is I think a lot of people it makes intuitive sense that you tend to associate with people who are roughly the same age as you, or within a range, and maybe the same nationality. I mean, you live in the same country as these people, so more likely that you'll come across them. But one that's kind of unintuitive that I think that doesn't get talked about a lot is genetics. There's some studies, I think Nicholas Christakis, who I interviewed, did one of these where he showed that we are more genetically similar to our friends than to random people in the population. And I think that might be part of the biological basis of some of the neurological stuff we're going to talk about.
Yeah, I mean, it gets into biological concepts like kin selection. You see this all across the animal kingdom, is that animals tend to group together to kind of protect their lineage, their line. And I think that that's kind of a foundation we've talked in previous episodes about kind of in-group, out-group behavior. I think we'll get into that a little bit more in future episodes. But I think that this definitely is one of those foundational things that's creating this kind of flock mentality. I mean, you think about schools of fish, flocks of bird, herds of mammals. There's something about that coordination of action, that coordination of coming together and doing all of these things together. I remember one time I was hiking in, I think it was in Utah. We went on this glacier hike, and we got to the top, and there was this huge herd of mountain goats. And it was the most fascinating thing because they sent what looked like the oldest one all the way down the glacier first. And then all of a sudden, every single one of them just kind of went together, all in sync, all in unison. And I think we're digging into human brains right now, but I think that some of these same principles might have been at play throughout biology, of this idea of really kind of getting on the same wavelength, syncing our behavior with the people or with the animals around us.
Yeah. So, and it does seem like there's some kind of emotional aspect of it too. I know the social psychologist Jonathan Haidt has done research on the kind of mass formation. I can't think of a good term for it, but I think we all know, when you go to a dance party or a concert or a dance party or a sports game, and you're all moving in unison. If you're at a sports game and you're doing the wave, there's a kind of a feeling that goes along with that. And I think we're going to kind of get into what might be the neurological basis of that kind of stuff. So maybe we can transition into how we know that, or what we know about the brains of people who are friends. Maybe you can dive into some of that.
Yeah. So I think we'll start with kind of a landmark paper that really drove a lot of my research interests. There's a researcher in California, Carolyn Parkinson, that did this fascinating study where she mapped out the social network in an entire group from the business school. I think it was like 400 something people. So she basically gave them a survey that was just like, are you friends with these people? And it had a list of like everyone's name. Are you friends with this person? Are you friends with this person? And so everybody filled this out, and she was able to map out the entire social network. Who was friends with who kind of clustered with who. But in order to do kind of the neuroscience side of this, neuroscience is expensive, especially MRI. So she couldn't put all 450 people in a scanner. That'd be like hundreds of thousands of dollars. But she took a subsample from that network, and she scanned all of their brains while they were watching certain types of video clips. And she wanted to make sure that there was kind of a wide array of the types of media that she was kind of sampling from. So she had comedy clips and drama clips and action clips, news reels, all kinds of stuff. Just getting kind of a sample of what normal people would probably engage with throughout their daily life. And she recorded their brain activity while they were watching these types of movies. And the fascinating thing that she found was that after scanning all of these people's brains, she could predict who was friends with who based on how similar the brain activity was in their brains when they were watching these different media clips. And to a certain extent, like she could say like, this person is two people removed from this person. They're friends of a friend, or they're friends of a friend of a friend. That as you got further away from the direct like bond with somebody, your brains actually became more dissimilar while you were watching these media clips. So there's something about kinship, about friendship, that may be driving the way that our brains represent information. But it is kind of, and this is something I still struggle with a lot, is it a chicken or the egg kind of thing? Did we become friends because we see the world the same way? Or is there something biological going on that as we become friends, our brains start to, what they call, like, entrain with one another? They start to kind of get on the same wavelength. We'll get into some fascinating research throughout this talk that may be leaning towards one of these, in terms of, like, there may be something that's prompting our brains to get in sync with one another. But there may also be something about kind of being friends and already being in the same culture, being exposed to the same types of objects and movies and media, that our brains are already kind of on the same wavelength. So still up in the air.
Yeah, you might think that, when you notice, like, hey, I like the way that guy thinks. I like the way he talks about stuff. Maybe that's you kind of noticing this similar way that your brains process information.
And that might have been kind of the basis for homophily in general, this idea of birds of a feather flock together, right? Is that when you get into, like, group dynamics, there are principles about attraction, that we tend to be attracted to people that have these similar qualities already. There's also the proximity principle, that, like, we tend to just kind of be with people that are around us, but the people that are around us are probably a lot like us too. They're in the same city, they're in the same kind of environment, they're probably around the same age. Like, so there's a lot of factors here that might be contributing to what's going on.
Yeah, and we can kind of dive deeper into this in a second, but it just occurred to me, the behavioral geneticist Robert Plomin, he talked about how people kind of their genes help them to, or influence them to, choose their environments as they go through life. So what you're saying, being in proximity with those people who are similar to you, maybe that's a result of this kind of, of course, there's going to be environmental influences as well, and all kinds of cultural stuff going on, but your genes may be influencing you to sort of associate with similar people, but that's all speculation.
And choose particular environments. We're kind of attracted to certain types of environments, just kind of biologically. And it could be, again, it could be very environmental as well. The way that we were raised, the types of influences and dynamics that happened in our family lead us to want to be in a dorm versus in a house versus this versus that. And so that's, there's a scientist at the university that I go to that they talk about the hard sciences, like physics and chemistry and everything. But he always jokes that psychology is the hardest science because it's so freaking messy. Like, there's so many angles to all of this stuff. But it's really cool that we're able to kind of chip away at this, like, one piece at a time, and really start to see the picture.
Yeah, that's why you study neuroscience. It's the easy stuff, right?
Right. It's not rocket science. It's just brain science.
Yeah. Okay. So on that note of what you study, you have a really cool, really interesting, I think we'll have to link to it in the captions for sure. But you have a 2021 paper about this phenomenon of people's brains resembling each other more when they're friends, and you really get into the weeds of how what that looks like in different circumstances and contexts. So maybe we should jump into that paper and kind of talk about some of what you found there.
Yeah, absolutely. So like I said, Carolyn Parkinson was this really big kind of motivation for the way that I wanted to kind of understand the work that I was doing. She kind of coined the term neural homophily, kind of based on this idea of, like, birds of a feather flock together, brains of a feather flock together, right? And so I wanted to see whether or not there was something there in terms of a friendship. So my mentor, Rob Chavez, had done a version of the study that we ended up doing at Ohio State. It was a really small version of it. There's been a ton of research in the whole, like, understanding myself versus understanding other people. But usually when they do these studies, the other person is kind of this fake persona. The researcher creates this random person, gives them some fake personality traits, and says they're similar, they're just like you. But there's this level of just, like, you're able to kind of see through it as someone that's participating in it. And so we really wanted to, and kind of working on his previous work, create an experiment that really brought real people in and got people to think about themselves, but also to think about people that they actually knew. This was one of the most logistically difficult studies I've ever participated in. So we actually collected groups of individuals. So we had sorority and fraternity groups. We had coworkers from local businesses that came in. We had roommates and friends. We had a bunch of people from like ROTC. So tons of different types of groups. And we brought in, each group had 6 people in it. So each person came in by themselves, and they filled out surveys about themselves. They filled out all of this information about the other people in their group, how they felt about those other people, what their social relationship was like with these other people. Because it wasn't all friend groups, right? You get a bunch of coworkers. There's going to be some variability in like who's friends with who, how close they are, these kind of things. And so we really wanted to see whether or not those social relationships were kind of coming into play when we're looking at how brains represent information in a similar way. And so I think right now is kind of a good time to make a distinction between this whole episode is about getting on the same wavelength, right? And there's 2 ways you can kind of approach that. So one of the ways is actually looking at using things like EEG. There's another technology we'll talk about later called near-infrared spectroscopy. But actually looking in real time, are the brains really kind of the brain waves getting in sync in real time. MRI, you can kind of do that, but it's also a lot slower. Your signals are really slow. And so it's harder to get some of that real-time information. What we're looking at in my study is shared representations. And so we wanted to dig in and really look in certain brain regions. Is the pattern of activity when you're thinking about someone or something similar between 2 people? So we're not scanning these 2 people at the exact same time, but we're having them think about the same things. And we're seeing if their brain, the pattern of activity, if like this part of the brain is super active and this one's kind of medium and this one's kind of low, is that constellation similar between 2 people? Because our brains, they store representations of things in the outside world, right? Some researchers are really interested in how we store semantic information about who was president and what kind of things we remember. I'm really interested in social information. I want to know how we store representations of ourselves, how we store representations of our friends, how we store information about people that we really know in kind of this stereotypical heuristic type way. And so we call it it's a round robin design, because we have these 6 people all thinking about each other. And so we're able to look from tons of different angles. Like, how does this person view himself? What goes on in his brain when he's thinking about himself? What goes on in his brain when he's thinking about Bob or about Sally? And how are those representations different? And how are they similar? And so this was really kind of the basis for what we were doing. My advisor actually did his original study. He found something called the self-recapitulation effect. That's a fancy word. But it was basically this idea that he found that I have a certain representation of myself when I'm thinking about myself. And he found that the group, their representation of me is actually very similar to my representation of myself. But somehow my self-concept is recapitulated in the brains of my friends, that they see me in a very similar way that I see myself. I wanted to kind of take this in a different direction, though. I wanted to really see whether or not when we're thinking about our friends, whether we have similar representations of these various people in our social support groups. And so that was kind of where I started. And so I was able to look. So I had 6 people. And so I was able to see, okay, this person has this kind of a representation of person 1, say Bob, right? This representation of Sally, this representation of Andrew, this representation of Taylor. And I was able to compare all of those with one another. I was also able to see what Bob thought about all of these people and see what his representations of all of these people were. And the really cool thing that I found that was kind of in line with this previous work from Carolyn Parkinson was that the social relationship between these people really mattered. So let's say that it was me, Andrew, and a third person, let's say Sally, right? If me and Andrew are really good friends, our representation of Sally is really similar. But if me and Andrew are not friends, then our representation of Sally is almost completely different. And so there's something about us becoming friends that is driving our brain to have certain kind of constellations of activity in our brain that are similar when we're thinking about these various people in our support groups.
And just to jump in there, so if we're, I mean, to kind of highlight a bit of that, if you and I know Sally equally well, but we're not friends, or the three of us aren't like a friend group, you're saying that you and I would have fairly different representations of Sally in our brains compared to if we're friends. Yeah.
It had nothing to do with our social relationship with Sally. It had everything to do with our social relationship with each other. As you and I became friends, our picture, our mental image of Sally became more similar.
Wow.
And this was really evident in regions that we know to be involved in social cognition. So there's a region in kind of the medial part of the frontal lobe, kind of right behind your nose here, that's, we know from tons of experiments is very involved in thinking about other people, kind of the dorsal region of that. And that's where we found kind of the strongest signals. We found it if you and I are very similar to one another, Andrew, we have a very similar representation of this person. If we're very close to one another. So there was really interesting stuff there. And we also took it kind of one step further too, because when you have this brain activity, you can actually average across the whole group. And so you can say, okay, this is on average how Taylor thinks about his whole group. And this is on average how Andrew thinks about his whole group kind of as a whole.
And just to drill into that a little bit, is it that you are averaging, so my representations of every individual in the group, or you're looking at my brain while I just sort of think about the group as a whole?
So no, this was actually averaging the individual representations of every person.
Okay.
So it kind of gives us this like normalized version of like, okay, this is how I think of Andrew, this is how I think of Bob, this is how I think of Sally. If I average those all together, then this is kind of how I think about my group in general. And what we found there as well was that there was this really strong relationship between, if you and I are friends, then this part of the medial frontal lobe is really similar when we're thinking about our group. There's another brain region called the anterior insula that has also been shown in previous research to be really involved in social cognition. And it's heavily connected to kind of the self region. It's kind of down low, kind of embedded right behind the frontal lobe. And we found that this was really involved in like individual people. You and I have a very similar representation of this certain person, but it wasn't involved in kind of the representation of the group as a whole. And there's some reasons. I mean, it's kind of speculation, but there's reasons that may be the case.
Why do you think that might be the case?
I think that the insula is very involved in kind of mood states and understanding kind of how I feel in this particular moment. And I think that the way that we did the study was we were asking people how they thought about these individual people. Now, I think that it could have been more tied to these individual kind of evaluations of people, but I don't think it's as abstract as what happens in the frontal lobe when we're thinking more about kind of these global properties of everybody kind of together in this average way. So, I mean, that is kind of speculation, but that's kind of how I think about it.
Yeah, because I was thinking that the anterior insula is involved in interoception. Is that right?
Mm-hmm.
Yep. Yeah. So feeling the internal sensations of your body, which, like as you were just saying, it would have to do with how you feel about these individuals. So maybe what you're thinking is like, because you'd have different feelings about the different individuals, the activity of the insula might not, it'd be kind of like wash out in the final analysis.
And that's a really good point, because neuroimaging data is very noisy. It's very messy. And so there may be, the insula might be involved in these kind of evaluative processes of thinking about how we feel about our group or whatever it may be. But when the rubber meets the road and you're actually doing an analysis, like what are you actually able to pick up on using this giant magnet and having someone in this tube and having these really slow dynamics because we're measuring blood flow. So it's amazing that we're able to find anything at all with MRI because of these really cool properties of blood being localized to these regions that are active. But yeah, kind of, I digress.
Right. So I guess we could think about if what do you think this tells us, if anything, about why we choose or why we have the particular friends we do? Maybe just having to do with kind of the stuff we were talking about earlier, the neural homophily and birds of a feather flock together. But what's your take on that?
I think that we have these very intense social needs as humans, and we have this need to belong, this need to be recognized, to be accepted, and I think that there are very salient feelings that go along with those needs of actually, because there's no way to actually verify whether or not we're understood, whether or not we are accepted. I mean, you can ask someone point blank, but they're going to use language to express that, and they may be lying, they may be telling the truth, whatever. So a lot of our kind of the way that we navigate the world is based very much on like the feeling and that the mood of that environment that we're in. And I think that I think from what I've seen from the research, some of the stuff that we're going to talk about kind of in the second half of the episode is that our brains are actually giving us these signals that like, yeah, we probably are on the same page as this person. We are kind of getting in sync with this other person. We already know biologically that there are things biologically that do get in sync, like with women that get on the same cycle, that are spending a lot of time together, right? So I think that there's something about that. There's something about being in close proximity with these people and sharing a lot of experiences with them and a lot of time with them, that it starts to give us this feeling that they are part kind of our self-concept, right? That we understand them, they understand us. They're not competing with us, they're cooperating with us. That's something I think that's going to come up in some of the other research that we're going to talk about. But that's a really good distinction, that we tend to gravitate to and form really strong bonds with people that we have these feelings from, right? And there's definitely exceptions to this, right? Because when we're thinking about group dynamics in general, and the types of people that we affiliate with, there are people that we choose to affiliate with, and there are also people that were kind of born in a situation where we are part of a family or part of a support group, and we don't really choose those people. And so you can end up in a lot of situations, even in romantic relationships, that you may end up not on the same wavelength. You may end up in a very, very like competitive mindset. And this feeling, and I'm sure a lot of the listeners can kind of relate to this, that the feeling in those moments, you don't feel connected. You don't feel on the same page, right? And so in terms of choosing friends and being with friends, I think that we are yearning for, and we're really searching for, that kind of intuitive feeling that we're on the same wavelength, that we're on the same page as these other people, that we're in tune in some way.
Yeah, that's a really good point, because language is kind of a blunt instrument for being understood in some ways. Like it's our only, it's well, I guess outside of visual arts and things like that, like language is the way that we can communicate thoughts to each other. But I think many people struggle with fully articulating what they're trying to say, and making sure that the connotation and the kind of emotional tone of it is correct. And we all know what that's like, especially with text messages. It's hard to like read somebody, and now with emojis you can add emotion. But all that to say that like we're searching for these ways to get on the same wavelength all the time, and language is the best way we have. But I guess we also have to look for these other cues, and maybe that kind of leads us into a discussion of neural synchronization, which is separate, or kind of a distinct concept from these shared representations that we were just talking about. So maybe you can talk about the distinction between those two things.
Yeah. So the shared representations, again, are more of this, we call it in fMRI, it's this multivoxel pattern analysis, really fancy term for just basically saying that we're peering into these brain regions and we're trying to see what that constellation of activity looks like, and matching up, like, does this constellation in this person's brain look like the Orion's belt in this person's brain, right? And that is this idea of shared representations. We're trying to pick up on how the brain is kind of firing and representing this stuff. Whereas the other side of this is more of a real time, are people's actual brain waves starting to get in sync with one another? And you can use, so the most popular for all of this is using EEG. It's been around for a long time. So EEG allows us to actually see brain waves. It's kind of more of a blunt instrument in terms of you can't really localize where that activity is coming from. You can't get a sense of these patterns that you can in MRI, but you can see kind of this population level. That you have these populations of neurons that are all kind of firing in sync with one another, that are creating alpha waves and gamma waves and delta waves. And what we see is that there are certain circumstances that we'll kind of dig into where these brain waves will start to sync up with one another if you're scanning two people at the same time. There's another really popular technique that's kind of growing right now. It's called near-infrared spectroscopy. So you're actually shining near-infrared light through the skull and measuring how it bounces back to the machine. And it's actually, you get similar images to MRI. So you're able to measure kind of blood flow and things like that. But the problem with near-infrared light is that the deeper it goes, the more it scatters. So you can only really measure activity that's really close to the cortical surface. So you wouldn't be able to get to like the anterior insula. You really can't really get to kind of the bread and butter of social cog stuff, of like the medial frontal lobe, but you can get some of the dorsal stuff, some of the outside stuff. And they're seeing with those as well, they're able to do that in more of a naturalistic setting. When you're working with an MRI, you're sticking someone in this giant noisy magnet all alone, which is this incredible task for a social neuroscientist, because you're like, okay, I want to understand how you think about other people, but I'm sticking you alone into this noisy magnet. So this other way of doing neuroscience is really cool, because you can put people in these naturalistic settings. You can have them interact with one another, cooperate, compete, do joint activities with one another, and you can see what their brains are doing while they're engaged in this kind of stuff.
Yeah,
it's called hyperscanning.
Hyperscanning, right? And
Yeah.
And an EEG is much easier to administer because it's like a head. It looked kind of like a shower cap, really tight, or a swimming cap, really, and then has like lots of electrodes all over it. But people can be moving around and doing stuff. So yeah, that makes a lot of sense. Oh yeah, and just on the shared representations, I don't want to spend too much time on this, but I do think it's cool to talk a little bit about what multivoxel pattern analysis is. So like, correct me if I'm wrong. It's you are just virtually slicing the brain into like these little tiny cubes called voxels, essentially. And then you essentially look at two people's brains by looking at the pattern of activity in every single one of those voxels, and then trying to look at like the correlation of the activity between like voxel 133 in subject X and voxel 133 in subject Y. I think that's fascinating that you all have figured out how to do that.
Yeah, there's a researcher named Haxby that really made this technique really popular. He's from Dartmouth. And the traditional way to do MRI neuroscience, it's what they call univariate research. So you stick someone in a scanner, you have them do some type of memory task, right? Remember this, don't remember this. And at the end, you say what brain regions were more active on average when they were remembering versus when they weren't remembering. And these are kind of the traditional brain images that you see, these blobs, was on average, that region was more active. It didn't say, and you're taking an average. So that whole region is like the same color, right? Because it was just like this region, the hippocampus was really active during memory. But it doesn't really tell you what the hippocampus is actually doing other than being involved in memory. And so what multivoxel pattern analysis allows us to do is, instead of just saying the hippocampus was active, now we're peering into the hippocampus and we're saying, what were they remembering? Is the pattern of activity in the hippocampus such that they were remembering a house, or that they were remembering an animal, or that they were remembering some type of tool? those are some of the traditional experiments that really kind of kicked off MVPA in the first place, is that they were actually able to categorize based on the activity in these individual little cubes, because a voxel is kind of the lowest unit of measurement we can get with an MRI. And if you take all of those cubes together and you kind of stretch it out into a line of numbers, essentially, like this is voxel 133 and this is voxel 133 in this other person's brain, you can line them up and you can say, is it the same across these two people? Are these two people representing houses the same way or tools the same way? And it was really cool because then we were able to take that technique and bring it into other brain regions. We can bring it into the frontal lobe and we can ask, this is where social cognition is happening. Is that pattern of activity representative of some type of salient social thing, social movement, personality traits, whatever it may be? I mean, at the end of the day, it's the researcher's kind of interest in what they want to try to compare those representations to.
So cool. All right. Well, let's dive into some of these experiments looking at neural synchrony, or at least some of the results, and just talk about the variety of ways that our brains can get in sync.
Yeah. So super cool field of research. So again, it was this rise of what they called a two-person neuroscience. And once we figured out that we could like scan multiple people at the same time, they're like, let's do like all kinds of different ways that people interact with one another. I think one of the traditional like early ones was having people play this 4-person card game with one another. So you had 2 people on one side that were cooperating with one another, and the other 2 people on the other side were cooperating, but then they were competing with one another. And what they found, I think this was with EEG, was that the people that were cooperating with one another, their brains started to get in sync with one another. So yeah, these 2 people were in sync and these 2 people were in sync. But when you looked across the table, the people that were competing with each other were not in sync at all. And that right there is fascinating, just because cooperation and competition are salient in all parts of your life, right? We're either cooperating with our friends, with our partners, with whoever, our family members, or we're in conflict. We're competing with them, and you can feel that. Like when we are like relaxed, we're together, and we're like enjoying things together, we feel in sync. And when we're not, when we're in conflict, when we're against each other, we don't feel that.
So interesting. Yeah, and I think one of the specific things they found there was that before, so I don't know what the exact game was, but there was something where they would lay down a card and then the next person would have to choose what card to lay down in response to that. And at that moment, that second person, or I guess the teammate of the first player, as they're laying down their card, that's when they their brain shows a really similar, is correlated to the pattern in the first player's brain. So there's like these specific moments, and I don't know if it's that they're kind of trying to read the mind about what was the intention of that last move, and kind of getting into their brain waves that way. But it's interesting how these specific moments when we're trying to maybe figure out what the other person was thinking, maybe that's part of this process of our brains becoming kind of in sync.
Yeah, because I think that there's kind of 2 ways to think about this, right? There's are we just generally getting in sync with one another, or is there also moments where it's individually driven? So I'm doing something, I'm kind of taking action, and the other people are kind of getting in sync with that action, right? There have been experiments in this domain in terms of leader emergence that actually show that when a leader emerges, that the other people are more in sync with the leader than they are with the other followers.
Whoa.
And so there's something about kind of getting in sync with that person that's kind of taking the lead, taking action. And this is in play with like playing music together too.
Right. Yeah. That I mean, there's that experiment that it's not just like playing music together. I mean, and that does make sense to me, that like a group of people would get in sync on that. But also they noted that just listening to a metronome together in a group of musicians could get them in sync. So it's like that. I mean, that's that seems like such a I don't know, trivial thing, but it's like we start to notice that cue of, okay, now I need to be on the same page as these other people.
And I think what's really kind of fascinating here and what's really interesting is what is causing things to, what they call entrain with one another, to get in sync with one another. So there's a neuroscientist who's like one of my favorite neuroscientists of all time, Uri Hassan, who talks about neural entrainment, of how our brains tend to kind of get into this mode where we're representing things in a similar way. And he has this TED Talk where he does this fascinating video explanation where he shows physical entrainment, right? So if you take like 6 metronomes and you start them all at different, so like all of them are kind of clicking in different sync with one another, and they're all on a wooden board. And if you take that wooden board and you put it on 2 kind of round discs, so that when this metronome moves, it causes movement in the board to affect the movement of the other ones, that all of a sudden, all of the metronomes start to get in sync with one another. So it's this idea of like, what is it that is entraining us? Because in that example, it was like connecting them via motion with one another, right? So what is it about us being around each other, about us being connected to each other in some way that is allowing our brains to do that? Is it some quantum effect that we don't know about that's like we're communicating telepathically? Or is it environmental? Is it the fact, like you just said with a metronome, if we're sitting there and we're all listening to the same metronome, that metronome is at a specific tone, at a specific frequency that is processed by our auditory cortex in very similar ways. We've seen this in tons of research, that when we listen to the same sounds, our auditory cortex does the same thing. And then that spreads to other regions that start to activate in a similar way. Like we all have the same circuitry. We all have auditory cortex. We all have these frontal lobes. Like,
no, I mean, I think it's the quantum goo or whatever. That seems
right?
more fun. Okay, so what are some? Sorry,
Yeah,
go ahead.
No,
I was gonna transition. Okay, so I mean, I think there's a lot of these examples, right? There's this, when you're trying to communicate your emotions to somebody through facial expressions, the areas of your brain and the areas of the person who you're communicating with, the areas of their brain, those same areas activate in similar ways. So like there's these other, I mean, it's all this stuff starts to seem intuitive. Like once you realize that this is a general phenomenon, it's like, okay, yeah, well, whenever you're really trying to be understood by another person, it seems like this phenomenon presents itself.
And I think there's something really important to consider with communication. And I think that this is useful for the people that are listening, because, I mean, we as humans have the ability to reflect, to really start to notice these things, right? To pick up on these cues of when we're in sync and when we're not in sync. And so I think it's important to understand these situations that may be driving it. And especially in terms of communication, there's a fascinating study that looked at eye contact. And that if we're actually making eye contact with the other person, that our brains are much more in sync than if we're back to back or if we're listening to a monologue. And so Andrew mentioned earlier that like all of you are probably to a certain extent in sync with us. And Andrew and I are in sync with one another, but not as in sync as if we were having a direct face-to-face, eye-to-eye contact. And so there may be something about looking someone in the eyes and actually having that kind of intimate moment that may be causing this kind of this bond and this synchrony to actually arise in the first place.
That is super interesting, because there is this, I can't remember what it's called, but there's this form of meditation that you do with another person where you're supposed to literally just sit very still and quietly and calmly and stare into the other person's eyes. And that's the whole thing. And it's supposed to kind of make you notice this feeling of like yourself being looked at by another person. And I guess the goal, if there is such a thing with meditation, is to kind of reduce that feeling of self that you have, that seeing this other person allows you to kind of not be so self-conscious in the moment. And that's kind of a coarse grain way of saying it, but there's some, I mean, I'm struggling to figure out what the link is there, but there's something about being in sync, or maybe just being in the presence of another person that does something to our social brains, and specifically our self-processing regions.
And I think that this, I mean, that really strikes a chord for me. So I'm a father. I have a toddler at home, and there's a lot of research just in general around attachment, right? Around creating these really strong bonds with our children at young ages that creates this really fascinating like self autonomous independence, lots of stuff later on. But a lot of this research is starting to get into that field of kind of mother-child bond, father-child bond, and they're actually doing these like hyperscanning studies with parents and their children, young children. And this is, I mean, as a parent, I've gotten into kind of the regulating together kind of thing. Children aren't able to regulate their nervous system as well as we can as adults. And so there may be something here in terms of getting on the same wavelength, that if I'm really trying to connect with my son, if I'm really trying in that moment to get on the same wavelength, and I'm focusing a lot on regulating my own temperament, my own mood, my nervous system in general, that translates to him being able to kind of pick up on that and to kind of self-regulate his down without having to have the ability to do that on his own. And so that may be a window into some of these processes. It could have a lot to do with pair bonding in general, in terms of like raising infants and helping them to kind of navigate their neural environment as they get older.
Man, that is fascinating. Wow. Yeah, I feel like we could dive into that for the rest of the episode, but there's one other paper that we wanted to talk about before we kind of zoom out and talk about this all as a whole. But language, we were just mentioning how language is kind of this blunt instrument for communicating meaning. Really, what are you trying to say to somebody? What's the content of your thoughts that you're trying to get to another person via language? And there's this really fascinating study that Taylor sent to me, and that I'm going to let him talk about because he knows it a lot better. But it's very cool, by that same Uri Hassan.
Yeah. So Uri Hassan is actually a language researcher. And he developed this fascinating new way to start like scanning two individuals and compare their brain activity using MRI. And this whole idea that Andrew was just talking about with language, that what we're essentially trying to do is convey some type of meaning. We have some understanding of what the meaning of that word is. And we want to make sure that when we translate that, when we use our words or whatever, that the other person is picking up on exactly that same meaning, right? And so he's done these studies where he's trying to see like whether or not our brains are in sync with one another to the extent of meaning. We know that there are certain high order areas of our brain that represent more abstract information, more meaningful information, right? The auditory cortex, the primary auditory cortex, which is where sound originally goes, is not really involved in understanding the meaning of an entire word. It's more involved in understanding tones and frequencies. So he did this fascinating study where he chalked up a narrative. And so this is kind of in two parts. I don't know if this is the exact paper you're talking about, but it's kind of these are all linked to one another. And so he chopped up this narrative into individual sounds. So he played it backwards at first, right? No meaning at all when you're hearing something backwards. But still, when you're hearing something, when two people are hearing the same thing that's backwards, that has no meaning at all, their auditory cortexes are still doing the exact same thing, right? But then he started to give them just random words, like just a jumble of words. There was no like sentence meaning or narrative meaning or anything. And he started to see this spread from the auditory cortex into the areas that were right around it. So we started to see that sounds were being turned into words. And so then he did sentences, and he saw this further spread, that now the sentences are being put in, or the words are being put into sentences. We're starting to connect things like noun-verb agreement, things like that. And then once he played full paragraphs and narratives, he saw that these regions like the frontal lobe, the default mode network, regions that are super heavily involved in social cognition and in kind of longer term information, across people were super similar. So when they were hearing the same thing, when they were hearing the same meanings of words, their brains were representing it the same way. But the fascinating, the research that he did that really just kind of blew my mind was when he brought English speakers and Russian speakers in. And they both listened to the exact same story, but one of the groups listened to it in English and one of the groups listened to it in Russian. And so when you're thinking about that, we've already demonstrated that if two people are listening to the exact same sounds, their auditory cortex is going to do the same thing. English and Russian are not the same sound, right? And so the auditory cortex was not in sync between these two people. But what was in sync were the areas that represented meaning. Just fascinating, right? These two people speaking completely different languages have similar patterns of activity when they're hearing the same concepts, not the same words, but the same concepts. And this is what really gets Uri Hassan interested in this idea of neural entrainment, because what is it about the way that we interact with our world, the way that we interact with our environment, that people from two completely different cultures that speak completely different languages somehow represent meaning in a similar way in these higher order brain regions, right? Is it that we're seeing a ball the same way that another person in another culture sees a ball? We define it differently, we use different sounds, but our brain is still seeing that, is still kind of creating a mental image of that in the same way as someone from this other culture, right? So this does get into kind of a different angle on this. And I think that's what's really kind of the basis for a lot of what we've talked about is like, what is actually causing these brains to be in sync with one another? And I, as a scientist, you mentioned earlier the whole like quantum thing being more fun. I teeter-totter all the time. There are instances where I'm just like, I'm a scientist. Like this kind of stuff is like out of the realm of possibility. And then there are other times where it's just like way too coincidental to believe that there wasn't something like bigger at work there. And so I constantly am on this kind of edge of like, is there something like that we can't really pick up on yet, that we can't measure yet, but somehow allowing our brains, like how do flocks of geese travel all the way across countries together, coordinating their activity together? Like, I know that there's like navigational stuff and things like that, but like, is there something going on that's allowing these animals, that's allowing us as animals to really be one with one another? I mean, that was the whole meditation thing that you just talked about, right? Like really kind of, if we can get rid of this ego that we've created, right? Animals don't have to get rid of it really, right? I think that they're able to get on the same wavelength a lot easier than when our own beliefs, when our own strivings and all of these things get in the way of actually connecting with other people, right?
Yeah. It's, I mean, it's, I was just thinking like with animals, I mean, if anybody has ever hunted with a dog or done anything like that, like worked with a dog or a horse or some kind of domesticated animal that you were able to get, it's hard to not even say it, like you get on the same wavelength with these creatures that can't even speak the same, they can't speak language whatsoever, yet you're using these really subtle cues and you're kind of learning each other and how do you communicate with one another. And it does seem like you're tapping into what's happening in their brain. And I was just thinking, I mean, from an evolutionary perspective, if you think about the brain as this enormously sophisticated, complex thinking thing, this object that allows us to navigate the world in really specific ways, and we're able to find food with it and remember things and remember where food was. And it seems like it would be so advantageous for a species through evolution to kind of tap into that resource that's all around them, all these other brains that occupy the world. If we can kind of get into them in some indirect way, we can really increase our own, evolutionary adapt our fitness,
Yeah, Absolutely. And I think that, I mean, going back to our first episode, that what I think is going to be a pretty common theme through a lot of what we talk about is the tension between independence and cooperation, right? And I think that that's salient across so many disciplines. Like philosophy has been talking about this forever. It's the difference between like communism and capitalism, is really about trying to find that balance between my individual pursuits, my desire to be this autonomous, creative individual, versus me actually embedding myself in a community and being a part of a community, being connected to these other people. And I think that that's something that we're constantly kind of fighting in ourselves. And that's what I think this whole episode is really about, is reflecting on those moments and saying, when are those moments that we really want to connect, that we want to really get on the same wavelength as other people? And when are those other moments where kind of it's more important to do the self-reflection work, to really kind of build up the ego and to be that kind of autonomous person? And it's not an easy thing to hash out, but it's something to tune into. And we have this amazing frontal lobe that actually allows us to think about it. So,
Yeah. And I mean, on that note, it seems like this idea of neural synchrony and especially shared representations has a lot to do with some of those larger social disagreements, debates that you were just mentioning. I mean, at the highest level of like politics, we see one side of the country has an idea about how the world works and what the human being is, and what's going to bring about the best future, and we have a whole nother set of ideas on the other side, and kind of everything in between. And I wonder if any of what we've been talking about can maybe help us to sync up our brains and find
right.
a shared reality. We'll always disagree. We'll always have different opinions on things, but I wonder if there's a way for us to kind of strive toward a more unified understanding of reality.
It feels good. When you
Yeah,
cooperate, when you get on the
that's
same
true.
page as someone, it feels good, right? So yeah, I think that that's definitely the case, and that we should all be striving towards a cooperative mindset, because that's ultimately what allows things to actually be resolved in the first place. When you look at conflict resolution, it's not about fighting, it's not about yielding or avoiding. It's about coming together and actually working things out and creating some type of structure around your differences, right? So I think we're at time. So don't forget to check out both of our channels. So again, my channel is the Cellular Republic. Some creative ways to help us out, to help especially my channel out. My wife has an awesome kind of gift shop. She creates these neuroscience and psychology and data science themed like shirts and mugs. It'll be on the link on my video. And of course, check out Andrew's as well.
Yeah, for sure. Yeah, I don't have cool merch, but definitely check out my channel, Sense of Mind, and let us know in the comments what you guys want us to talk about in the future. We've got some cool ideas like brain decoding and mind reading, and some fun stuff for the future. But if there's anything specifically that you think would be cool in the future, definitely let us know. And we want to make this more of a conversation as time goes on.
Yeah.
So just don't hesitate to comment and reach out. And yeah, thanks for being here.
Yeah, thanks for listening. We'll see you guys all later.
All right. See you guys.